All right, we're going to talk about the speed of sound lab. For that, we need these measuring tapes, which are right here. Um, if you are watching this, later in the year, when you might actually be doing this lab soon, well, you already know where these measuring tapes are, I'm sure, by now. But anyway, there's the measuring tapes. So students will need one of these. It's also an option to use one of these, I guess, or one of this one. But it's better to use these guys because they're stiff, and you have to measure the interior distance of this orange tube. Right? The idea here is really simple for this lab. You're going to send a sound, and it has to be a finger snap. Nothing else will work for this lab. It has to be a finger snap. So if students can't finger snap, you might need to just rearrange the lab groups until every lab group has a finger snapper in it. And basically you measure the interior distance, like how long this tube is from the front to the back. When you're trying to slide this thing in there, it might get stuck on a couple places inside the tube, so it's really important to shake it around and make sure it gets all the way to the back as you pull it out, right? Pulling it out and pushing it in there. You need to make sure to shake it around until it's all the way in, all the way to the back. Students will need to do that, that is. And then it's also really important that this microphone gets lined up exactly with the front end of the tube. Because what we're going to do is we're going to measure the sound of the finger snap as it enters the tube, and then it's going to echo off that far end and come back again, and then we will measure the sound as it comes back as an echo. And that's going to show up on the computer screen as a set of squiggles, right? Sound pressure waves. So there will be some sound pressure waves for the initial snap, and then some sound pressure waves for the echo of the snap. So there's images of sample snaps in the instructions and the worksheet for this. So hopefully the instructions there will make sense for how to do this lab. But this is how you set it up. And then that guy would be hooked up to the Lab Pro, which is hooked up to a computer, which is then logged in, which is then using Logger Pro to collect the data. And that's how you do this lab. Finger snap, collect the data. There is a file which is should be in the in the folders on Google Drive. Hopefully, there is a copy of this file that's already set up, and you'll need to email that to the students so that they can open it in Logger Pro, and it will already have all the settings ready to go for this lab. Kind of important, there are settings that need to be ready in order for this lab to work, and they're kind of complicated. So I made a file with the settings already in it. So that file should be in Google Drive. If it's not, you can email me, and hopefully I will be able to answer you, even though I'm on home assignment. You can try to email me, and if you can't find things you need, and hopefully I'll see the email in time to respond. Anyway, that's it for this video. Measuring tape, this thing, tube. Oh, where are these tubes, you might wonder? Well, let's go put this one back since I'm done showing you what it is. These tubes are all right here, back in the corner. Right there. 6 tubes. Unfortunately, at the moment, there only seem to be 5 of these microphones. And I'm not sure where the other one is. It's possible it's in Mr. Barner's room, the chemistry room, L4, next door. So I don't know. I doubt I'm going to have time to try to find all these things that are not where they're supposed to be, or possibly just gone. Maybe somebody borrowed them. I don't really know. COVID happened and all kinds of stuff now is disappeared. So anyway, thanks. That's it for this video about the Speed of Sound lab. It's actually a really good lab, and if it's done properly, you can get to within, less than 1% error of the actual speed of sound in air. Which in this room, if you have it air conditioned to 25 degrees, the speed should be about 346.5 meters per second. So, all right, good luck. Bye.